should we then abandon scientific realism and embrace constructive empiricism? Well, the realists are not going to be impressed, and here are two possible realist rejoinders. The first one would say that the notion of empirical adequacy doesn't really do when it comes to explaining the success of science, and von Frassen's Darwinian reformulation of the numerical argument doesn't really cut any ice. One thing is to explain why only successful theories survive. Another thing is to explain what makes a theory successful. So the scientific realist would claim that she has a story to tell about what makes a theory successful, namely that the theories that survive are successful because they are true, because the entities that they postulate are real, and because what the theory says about those entities is true or approximately true. The theories that didn't survive, the theory that failed because they were simply false, like the ether theory or the phlogiston theory or the caloric theory. So this is the first rejoinder against von Frassen's reformulation of the numericals argument. The second rejoinder attacks von Frassen's distinction between the observable phenomena and the unobservable entities. This distinction has been at the center of a very voluminous literature, which I won't have the time to cover today. But philosophers have been concerned about the way in which this distinction is drawn or can be drawn, because it seems to be too stringent as an empiricist criterion. Why should we not rely on our scientific instruments, be they an electron microscope or a particle collider, to deliver us a reliable image about what there is? Why should we trust our naked eye more than our scientific instruments? So here I won't enter into the intricate details of the arguments pros and against the observable and unobservable distinction, but I do want to mention one prominent realist response to constructive empiricism, and this is a response that has been formulated by two philosophers of science, Philip Kitcher and Peter Lipton. The response says that we are justified to believe in unobservable entities because the inferential path that leads to such unobservable entities is one and the same inferential path that leads us to unobserved observables. So, what is an unobserved observables? Well, consider the many ways in which perfectly observable objects may go unobserved. None of us has ever seen a dinosaur, yet if we could travel back in time, we could in principle be able to see a dinosaur with our naked eye. So a dinosaur is a classical example of an unobserved observable. So people like Kitcher and Lipton have been arguing that we are justified to believe in electrons, atoms, DNA sequence, unobservable entities on the same grounds on which we are justified to believe in dinosaurs. So how do we know about dinosaurs? Fossil evidence is what paleontologists use to reconstruct the past history of our planet. From fossil evidence of this type, we can reconstruct some important information about the life of extinct marine species, like these trilobites in the Paleozoic era. For example, we can come to know whether they swam, they moved on the seabed, whether they ate plankton, how many different genera there were, how geographically distributed, and so on. But as fossils provide evidence for now extinct species, similarly, one can argue, the Large Hadron Collider's outcomes can provide evidence for the elusive Higgs boson. The inferential path to the unobservable Higgs boson is one and the same as the inferential path that leads to the unobserved observable trilobites. Philosophers of science calls this inferential path inference to the best explanation. The idea behind inference to the best explanation is that we infer the hypothesis which would, if true, provide the best explanation of the available evidence. Thus we infer the existence of marine arthropods like trilobites, because this is the best explanation for these fossils, as we infer the Higgs boson as the best explanation for the sort of evidence coming out of the LHC. Namely, we choose from a pool of competing explanatory hypotheses the one that we regard the best, the one that, if true, would provide a deeper understanding of the available evidence. Inference to the best explanation is a powerful tool in the scientific realist toolkit. It shows that scientific hypotheses that we choose and we are willing to believe tend to be those that would provide a deeper understanding, the best explanation of our evidence. And this is what we tend to do every day in life. For example, in medical diagnostics, when the doctor infers the hypothesis that best explain the patient's symptoms, as well as in astronomy and cosmology, when we infer that the universe is expanding as the best explanation for the cosmological redshift in the spectrum of the stars. The realist would say, this is what science is all about. We don't rely necessarily on our eyes or technological instruments to believe in the unobservable entities, but on the validity and robustness of our inferential practices informed by a wealth of experimental data in order to draw conclusions about how our universe is going to be like.